Hi, everybody. I want to welcome you today to this talk, Supercharge Your Debugging, Debugging Tips and Tricks with Visual Studio 2017. My name's Casey Anderson. I'm a program manager who works on the debugging team. So what are we going to do today? What are we going to talk about? First of all, why are we all here? We're all here to learn how to best debug your code, right? What are tips and tricks you can use? Because guess what? None of us get paid to write code. We get paid, or none of us get paid to debug our code, right? We get paid to write code. And so the less time we can spend, trying to debug the code and fix the issues, the better off we're going to be. So hopefully today, you'll walk away with something new that you've learned. Raise your hand if you've been to a debugging tips and tricks session before, either at a previous build or seen one online. Okay, not even half the room. That's awesome. So hopefully the rest of you who've never seen this stuff before will learn something new today. We're going to be doing a very demo-heavy session. I have 30-plus tricks and tips for us to talk about today. And then we're going to do this Marvel movie style. So at the very end, if you stay through the credits, I'll throw a teaser trailer your way for something to come. Sound good? Everyone excited? Okay, let's jump in. Okay, so here I've got Visual Studio open, and we're just going to start debugging. My application comes up, and it says, hello, provide conference flag argument. This isn't what I'm expecting to happen, of course. So because we obsess over our customers, you guys really are my favorite people, and I want to, when I present this, I want to greet you all personally. But I don't want to hard code, hello, build peeps. So one thing I've done here is I've used the project properties of my WPF application. So when I right-click on the project and I go to properties, it'll open the project properties page. And right here, I can add command line arguments. So because I want to greet you personally, the command line argument that I want to pass in with this conference flag is build peeps. Because that's you guys, you're my build friends. And this project properties page has some other things that you can do. You can, for example, configure it to start an external program. So if you're doing some like office development, for example, and you're writing just some library code, you can start up perhaps Excel, and then when that code calls into your library code, the debugger will be attached and will break there for you. And the other thing, you can also enable other debug engines. So if you're doing some mixed debugging, if you're debugging managed and native code, you can come and select those options here. So when you F5, we can attach like both debug engines for you to use. So now I'm going to hit start, and I expect this to say, hello, build peeps. And then it doesn't, of course. So I've got a bug in my code that I've got to go fix now. Clearly, this is in the startup path of my application. I haven't pressed any buttons to get here. But I'm not quite remembering, maybe it's just stage fright, where my application startup entry point is. So did you know that you can start debugging by stepping directly into your program? So when I hit F10 or F5 here to step into, my instruction pointer lands me on the first line of code that gets executed by my application. So this opened that up for me, and I can immediately start, debugging, just walking through my code and seeing what's happening. Well, I'm initializing my string provider, and then I'm forming my greeting. And when I step over that, if I'm looking at my locals window, this greeting is hello conference. So this is the variable that's being returned, the garbage that I want to go in and fix. Well, I already stepped over it, first of all, but it also has a bunch of method calls in it. So it's got get greeting, get conference, get punctuation, and I want to know what those returned, and I can't necessarily hover over them. Well, if we direct our attention down to the locals window, you can see that we have return values provided in the locals window. So we can see that get greeting returned hello, get conference returned conference, and get punctuation returned the exclamation point. So get conference is my issue, and I want to go debug into that now. One more note about return values is that if you're used to using the watch window, who here loves the watch window? Is that your favorite place to party? Okay, a lot of you. So you can actually get return values in the watch window, so you don't have to switch back and forth by doing $ return value. And these are, 1 to n. So return value 1 will be the first argument of my that gets returned, and the second one will be the second, and so forth. So that's something to help you if you love partying in the watch window. Now, we established get conference was my hang-up point, my issue. And so I want to go debug into that. Well, you know, I'm going to have to restart my whole application to go up the line and debug into that because I've already stepped over it. Or you can use another great tip, which is the set next statement feature. So if I want to just move my yellow instruction pointer back, so in this code, I haven't necessarily done anything too risky. And so if I want to move my instruction pointer back to this line, I can right-click on the line of code and say set next statement. I can also achieve that by grabbing this yellow arrow and dragging it around. Now, just to point out that when you move the yellow arrow, it doesn't actually reset any state in your program. It's literally just telling the debugger, hey, this is the next instruction, go execute it now. So if I were to step into this line of code, we would step in to get greeting. Greeting wasn't the issue, get conference was the issue. So I'm going to use another feature in this context menu called step into specific. So when I right-click on that line of code that I'm stopped at, it will give me a list of options, all the available functions that I get to step into to go debug. So I want to step into get conference. So I'm going to do that now, and it's going to land me. It's going to run the code and land me at the first line of get conference. Great. So this is my problem function, my little problem child function right here. So what's going on, right? As I read through it, I want to come down here inside this if statement just to take a look at more variables. I could do that. Who here has used run to cursor? In that same context menu, you right-click and you use run to cursor, Control F10. Raise your hand, high and proud. Awesome. That means that you guys are the lucky few who have actually discovered this at some point in your life. And it's a huge help. So I can run to cursor from the context menu. Well, in 2017, we heard a lot that was so useful but so not discoverable, and kind of a pain to use. Even I, that I know it's there all the time, I don't want to find it in the context menu. It's just too much for me. So we've built this new run to click feature. It operates the same as run to cursor, but it's an adornment in the editor. So when I zoom in here, you can see this, and then maybe I'll zoom in just a little more. You can see this button right here. As I hover over the lines of code, that run to click glyph appears next to the line of code. It's really non-obtrusive, and when I hover over it, you can see that it's a button that I can click on. And so now my instruction pointer is not going to set next statement, but it's going to run and stop at this line of code. So we've enabled basically point and click debugging. Whoop. We've enabled basically point-and-click debugging for you. So I typically always have one hand on the mouse anyway to inspect variables with data tips. And so this is a great way to be like, hey, I want to go here, hover over. There's no more step over, step over, step over, OK, mouse, and back and forth. So now that I am at this line of code, thanks to run to click, I'm just going to inspect my arguments that I'm passing in. And the conference flag is the first argument, and build peeps, that's you guys. Give me a cheer. We just had lunch. Let's all cheer. That's you guys. You're my build peeps. Thanks for waking up. I appreciate it. So now that I see that it's the second one, this x is only at 1. So I need to actually just add 1 to it. And I'm able to do that without stopping debugging using edit and continue. So I can make changes right in my code while I'm debugging. And now, when I continue, conference actually picks up the right argument, build peeps. There we go. So now I'm going to step out of this, and I'm going to come back to this line. So I ran get greeting, I stepped into get conference, and now there's get punctuation. And let's just follow that through. So I'm going to step into get punctuation, which calls into get exclamation, which returns the right thing. So one of the things I wanted to point out here was that I can use that same run to cursor feature from my call stack. So I don't know if any of you have experienced this, but sometimes you're tracing through a problem and you go step into, step into, step into, step into, and all of a sudden you're 10 layers deep. into your application. And you can use the call stack to orient yourself, but then still, to get back to where you started that investigation from, you'll have to step out just as much as you stepped in. Well, you can use run to cursor from the call stack, and when you right-click on the frame of the call stack that you want to target, and then select run to cursor, it will pull you back out. So it's doing like all of the step outs to get you back to that frame on the call stack, which is pretty fun. Great. Oh, and then just to prove to you that I fixed my issue, we're now greeting you properly. Hello, build peeps. Now, let's just give a quick recap of some of the execution control that we started with. And one of the reasons I started with execution control is that's the basics, right? That's the beginning. That's where we're going to start. We're going to do demos like that for about the next 50 minutes. And we're going to kind of go through, we just did execution control. We're going to go through variable inspection. We're going to end with some multi-threaded tips. And then the Marvel secret teaser at the very end. Cool. So jumping back into my application, I'm going to just go ahead. I have this application. It's a repository that I'm working on with some of my coworkers. We demo apps at conferences like this, and we're just trying to keep track of some of them. So we're just building up this little toy app, and I'm going to practice loading the data just to make sure that that's happening properly before we move on. So when I clicked load data, you can see that I stopped inside the debugger. There's no breakpoint set on this line, but you can see that I have a debugger.break in there. So you can hard code breakpoints into your application by using the string, the phrase, the code, debugger.break. And so what's happening under the covers with the debugger.break is it's throwing an exception in your code that the debugger is saying, hey, they want to break, and then we're handling that and then putting you on the line of code that you want to get to. Hard-coded breakpoints are great if you are going down, if you have a bug, maybe in a really complicated execution path, and you just want to, anytime that path runs, you kind of want to stop there for sure. And maybe you're doing other stuff with breakpoints that are transient, and you don't have to be afraid of deleting all your breakpoints and starting over because you know this hard-coded breakpoint's there. You'll also see that it's wrapped in a debugger.isAttached. This is for two reasons that are good for debugger.isAttached. One, like I mentioned, we're throwing an exception under the covers that the debugger handles. So when the debugger is not attached, that exception would end up taking down your application. So if you wrap it in a debugger.isAttached, when you run this code in release mode without a debugger attached, you're safe and good to go. The other thing that debugger.isAttached is great for is when you maybe want to play around a little bit in your debug session and take a different code path, set some different variables, really just have a little workspace that you can use to say, hey, while I'm debugging, let's try out some stuff. And then you have that code right there that will only execute while you're debugging. So you can get the information that you want to diagnose your issue without it affecting any release code in your application. Now, I mentioned we're going to do some data inspection. How do we use variables and how do we look at this information? So let's inspect my data provider first. In my data tip, which is what we call the thing when you hover over a variable, in my data tip, I've got a lot of information here. We also have 6 visualizers in the debugger. So if you have ever seen this little magnifying glass but never clicked on it, this is what we call a debugger visualizer. You can select what kind of visualizer you want, and we'll give you the available options. So if I want a text visualizer, I can see, instead of reading all that out vertically or in a tooltip, I can get that information in a really compact way inside this text visualizer. Now, this happens to be a JSON string, so the text visualizer isn't that helpful. What I really want to do is see this thing in a pre-printed JSON way. So I'm going to click on the JSON visualizer, and it's going to show me kind of the visualization of it, and I can also search here. So if I want to know about my app IDs, for example, I can search through that, and it'll pull up all the app IDs. So this is a really good way, the visualizers are a really good way to start looking, drilling deeper into some of your variables that may previously have been hard to parse. Just running down the list, we also have an XML visualizer. So you can view your XML that way. And we have an HTML visualizer. There you go. I mentioned we have 6 visualizers. The other one that I'll just call out real briefly is our WPF visualizer. So down here, I have my WPF object, and I can use my WPF visualizer to pull this up and inspect this object while I'm debugging. And it's got my visual tree here and my properties. Cool. So visualizers are also an extensibility point in the debugger. So if you have objects that you deal with on a regular basis for your application, and you wish there was a better way to view those in a prettier fashion, we have documentation online for how to write your own visualizer and then use it in your application so that you can better inspect your own objects that you're writing. Cool. Now, speaking of things that are helpful when you see them, I have an array here that has all my apps in it. And when I look at this array, it's not very helpful. It's just returning the type. It's just returning app info. And so if I want to make sense of the objects in this array at all, I'm going to have to drill into each one and say, oh, OK, this is app 5. It's a web app. And then I'm going to have to go to the next one. OK, this is app 4. It's a web app 2. I wish there was a better way to view this string in the debugger. And so there actually is. There is a better way. So we can go into our app info class, and we're going to add a debugger attribute. So I'm going to use Alt F12 to go into my app info class, which opens the peek window. So while I'm debugging, if I'm in one place and I just want to stay there, I can use the peek window to get a glimpse into other areas. And I can also edit inside here. So I mentioned a debugger display visualizer, like attribute, that I'm adding. So we're going to type in here debugger display. And I'm not getting any IntelliSense. So when I control dot, control dot is the light bulb. We've probably seen this before. But I'm going to include using system.diagnostics. And now I'm going to get the rest of my IntelliSense. I'm going to get the rest of my IntelliSense so I can fill out what I want in my display attribute. In this case, I'm interested in my app ID, and I'm going to use curly braces to say, hey, give me the value of app ID. For some reason, I can't remember if app ID is uppercase or lowercase, so I'm just going to hold the control key and peek through my IntelliSense there. And this works for data types also. You can hold the control key to make things that are hovered transparent. And so I can see now, oh, ID is capitalized. So I'm going to type app ID with capital letters inside the curly braces here. And so now next time I run this and get to something of type app info, it's going to show this instead of just the object type. Now, I'm going to have to restart debugging because this purple squiggle underneath my code here means that edit and continue won't work in this particular case. So when you see purple squiggles, that means that the edit you've made, you have to restart your debug session in order for that to be applied. So I can use, instead of stop start, I can just use the restart button right here to restart my application. We're going to click load data again. It's going to hit my hard-coded breakpoint. And when I hover over apps, and I can see now that it shows me, oh, app ID 0, app ID 1, app ID 2, app ID 3. So with these display attributes, awesome. So with these display attributes, we first look at toString. And if you have toString implemented, we'll show that. But if not, then we look for debugger display attribute. And finally, if we can't find either of those, we default to the object type. So now I've been playing around inside data types. And I mentioned what those were earlier. I'm pretty sure, hopefully, we're all familiar with data types. But there's a couple extra cool things about data types you may not know. So if I'm just going to run down here inside the for each loop, and I have a for each loop here that's iterating through every app in my application. So I want to inspect this app every time. I want to say, hey, is this app 0? Is this app 1? What's the name? What's the handle? I'm actually going to use this little pin that's next to my data tip, and I'm going to pin this data tip inside my code window. So it like scrolls with my code window. And now as I'm debugging, and if I hit this line of code again, you can see that the app changes, and just at a glance, I can say, OK, I'm on app ID 1. And that's really helpful in things like for loops or sometimes even if statements to just get a quick glance of what that is executing. And then once it's pinned, you can also add to here. So if I right-click, I can add expression. And let's say I want to add app dot language. So this has one language here. And it is app dot language is just one there. So and so you can basically create watch windows that are pinned inside your editor if you have a wide array of things you want to look at. OK, so we'll just go ahead and remove that expression and keep it simple here. So now, as I'm running through this application, let's say that, hey, app ID 1 is kind of the important app, and maybe I want to compare it to the next thing that comes through this for each loop. I can right-click, and I have this option that says Make Object ID. So when I create an object ID, down here in the locals window, I'm getting a handle to this object. So it created this thing says $1, and right now it's app ID 1. And so next time, I can also, in my watch window, use this, $1 here, just like I can use return value, and I can also add my app. And so next time I go through this loop, let's just use run to click and run to the next one. As this changes, app ID 2 is now my local reference for app, but I still have a handle on app ID 1, so I can compare things like the app type across multiple runs of this loop, even though my local variable isn't there anymore. So there is a little bit of overhead in maintaining these object IDs. So I'm going to make sure you delete the object ID when you're done using it. So I'm going to right-click and delete object ID, and then I can backspace to clear it out of my watch window. And then the last thing I want to show you in terms of variable inspection is that these apps, they're property dense, so they've got a lot of information to inspect. Sometimes a data tip or a watch window isn't the right place to do that, so you can actually use the quick watch window. And so that's Shift F9. But it's available here. It's kind of a modal window. You can make it big screen, and this is awesome if you're dealing with multi-mon debugging. You can throw this on a screen to the left, and even though it's modal, every time I close it and reopen it, it'll reopen in the same size and the same place. So if I ever need just a big scratch pad to look at all my variables, the quick watch window is really quick and dirty for that. Cool. OK, so we just kind of looked at some data inspection techniques. And what's the next thing we're going to look at? So we just did some data inspection. Here's a recap of that. That's you're seeing right now. The next thing we're going to look at is, once I get this set up here, well, let's talk about breakpoints. Let's talk about them in a second. First, I'm going to run my tests. So I've got the data loading properly, and let's run my tests. Uh-oh. Web passed. Mobile passed. Desktop failed. Wah, wah, sad face. I've got to go debug into this and figure out what's wrong. Because it's just my desktop test that is failing, I already have kind of a picture in my mind about where I probably want to go set this breakpoint to hit this again and debug through that code. So I'm going to use control comma, and control comma opens this go to all feature, and I'm going to go to my get apps by type method. So I went straight here, and I think this is where my issue is. I'm passing in each of the types, so let me just set a breakpoint here. And let's hit that breakpoint again. OK, so in this code path, I've got a decoded type here, which is web. Now, notice that web was passing, so I don't really care about the path that web takes through this application. What do I care about? I care about desktop. So using this breakpoint, I'm going to set a conditional breakpoint. When you hover over the breakpoint, you see this little toolbar that pops up, and you can go to breakpoint settings. So we have conditions and actions as a part of our breakpoint settings. And so the actions field is for, has anyone ever heard of a trace point before? Trace point? A couple shy people saying, yeah, I've heard of that. What a trace point does is if you're used to printf debugging, you have to add code to your application that spits out variables for you. With this actions field, you can log a message to the output window, and then it'll continue execution. So it doesn't actually break. It'll just spit out the message you tell it to. So you can put in plain text here, that will get printed just as is, if I can type. And then you can also use curly braces like we did before in our display attribute. And so anything inside the curly braces will give you IntelliSense, and then it will actually be evaluated to that value when it comes out in your console or your output window. And lastly, you can add, we've got a rich set of pseudo variables for you to take advantage of. So you can take advantage of, for example, function, which will print the function in which this trace point gets hit. The other thing you can do is conditions. So in this case, I was interested in when decoded type equals desktop. So I'm going to type in decoded type, and I get IntelliSense here. And I want to say, OK, when that equals desktop, that's when I want this breakpoint to be hit. So now I've just set a condition where this breakpoint won't be hit unless it's true. We also have hit count and filter breakpoints in here. Hit count is great if you're inside of loops and you don't want to break on the or you don't want to step through 105 iterations of your loop. You just want to be like, hey, I know this is a problem. Let's get there. Let's speed this up. So do a hit count breakpoint and then put the number that you want that breakpoint to hit, and then stop. The last one is filter breakpoint, which is great when you're dealing with threaded applications, and we might take a peek at that later. So you can filter by machine name, process ID, process name, or thread. OK, so now that I have my breakpoint set, let's hit continue again and say, now we can see that, OK, decoded type equals desktop. That's where I'm stopped on. I'm using a Lambda, a link query here. And let's just go ahead and go to the immediate window to kind of break that down, play with that, and take a look at what's going on inside that Lambda expression. So down here, first, let's just make sure there are items of type desktop in my application set. That could be a really silly mistake I made. So I'm going to type data.applications.select. And then we're going to go A in a.apptype. And we're going to say distinct, and then dump that to a list. OK, so I can see I do have 3 distinct types of objects in my list, mobile, desktop, and web. And in doing this investigation, I might be able to see an issue. Desktop here has a capital D, where when we did our conditional expression, and right here, desktop has a lowercase d. Could it really be that simple? I don't know. Let's find out. I'm going to use the immediate window again to just copy this line of code that I had up here. And then my hypothesis is, let's say, OK, if I ignore my case, so let's do system.string comparison, ordinal ignore case, ordinal ignore. There we go. Case, camel case matching. Nope, that's not what I wanted. I had to hit enter on it. There we go. OK, so now when I run this, I'm actually getting apps returned of type desktop. So you can see that that list has about 7 objects in it. So before it was 0. So now I'm going to take this. I just did that experimentation really lightweight in the immediate window. So the immediate window is a really good scratch pad while you're debugging. So in cases where you're like, hey, I've got all this data. I just want to manipulate it and to understand it better and to see what's happening, pull up that immediate window, play around with your data. You can even change variables inside there if you want. It's a really powerful tool that you can use to really help you debug faster. So now I'm going to just take that same code and put it in my regular my actual application. So now I've changed it, and I'll delete this breakpoint, and hopefully, again, when I hit continue, whew, thank goodness it's all green. All of my tests pass. I always like to take a deep breath when I see green check marks everywhere. It just makes me a little happy. So, great. OK, so now that my tests are passing, let's load up the apps. Let's take a look at what those apps are. So I'm going to get my apps, and I see, oh, I have a list of all my apps returned. I can see my mobile apps. I can see desktop apps. I can see web apps. Does anyone else feel like this is a little slow? Like there's a little bit of a blink there when I'm transitioning through these apps. And when I click Get Apps, that actually felt more snappy. So I'm kind of guessing that I have like a little perf problem that's going on in here. I'm not actually going to stop debugging and start a profiling session to figure this out. I'm going to use the debugger to help me figure out why this isn't as snappy as maybe it should be. So the button I was pushing was load by type, so I'm going to use control comma again, and I'm just going to go to that load by type method. And I'll just set a breakpoint at the top of it. And let's just go ahead and put a breakpoint at the bottom of it, too. So now, let's shrink this down a little bit. Now, I'm going to hit that breakpoint. Load by type. Let's load them. Great. So now that I've hit that breakpoint, and I can take a step, too, you can see this little glyph over here on the right of my code line. This is called a perf tip. Here, we'll zoom in so you can see that nice and big. So this is called a perf tip. With the perf tip, it's an order of approximation indicator that tells you how long that code took to execute. And so I say order of approximation, and that's why this says less than or equal to, because you know, as I run to the end of this method, and I get to the bottom, it says 623 milliseconds occurred. Now, if I go back to this breakpoint up here, and I can drag my execution pointer back up there, maybe this is a good time for an interjection. I know we're fixing a perf issue, but I'm keeping you on your edge, right? So here's a pre-teaser for you. I showed you run to click earlier, right? And it runs execution to this line. So when I click run to click, this will skip it. What I really want to do is use set next statement here, and I could drag the yellow instruction pointer up, but in the future, it would be nice if I could just hold down the control key and just directly set next statement to this line. So that's something that's coming for you soon. Point and click set next statement as well as run to cursor. Thanks. Point and click debugging is the future. I'm going to make it happen. So order of approximation perf tip. When I run this again to the end, you can see, OK, now it's 660. Before it was like 626. So these aren't 100% going to be the same every time. But we've taken out the debugger overhead in Windows 10. We've done some stuff. So these are actually pretty accurate. And I don't think this whole thing should be taking 660 milliseconds. So I'm going to put my execution back up here again. And let's just step through line by line and see where the bulk of this time is happening. OK, I found it. So even just stepping through my code, I probably could feel that. But sometimes, 500 milliseconds, that's hard to feel. That's almost imperceptible as I'm debugging. So I can see this function here, that's probably where my issue is happening. So I'm going to go ahead and step into this now. And now I'm in this function. As I step through it, OK, I've hit this button a couple times. I feel like it should be cached. But it's not being cached. So what's happening? OK, I'm creating my server cert. I'm just not adding it to the cache. So what I need to do here is I need to go and add it to the cache. So certificate store dot add. It looks like we're adding by base URL. And then we'll just pass in the server cert. OK. And so now, when I step through here, that has been added to the cache. And when I run this whole load by type again and finish it out, it takes less time. And let's just test the whole function now. Start from the beginning and go to the end. OK, only 19 milliseconds. So after it gets cached the first time, I just fixed kind of like a really big perf problem in my application, just using this little perf tip to clue me in on where the majority of my time is happening. I'm not a profiling expert by any means, but I was able to leverage this in debugger tool, and I hope that you do too. Great. So I mentioned I'm not a perf expert, but I do keep the diagnostic tools window open over here. Has anyone seen this before? Raise your hand, high and proud. Now, has anyone closed this? Raise your hand. Yeah, same people, right? So I'm going to encourage you to keep this open, and here's why. First of all, if you need to get it back open, you can always click on the perf tip, and that'll open the diagnostic tools window. So if you do need more space, close it out. The perf tip's always there. Click it. Instantly, it comes back. In 2017, we made this window smaller by default and added this summary page here. So I can still see my swim lane graphs, the process memory and the CPU. And I can now take actions from my summary tab. So I could take a memory snapshot or enable CPU profiling right from here. And if you have IntelliTrace, which is a Visual Studio Enterprise feature, it'll show me the number of exceptions that are occurring as my app is going along, those that are being thrown and caught that I'm not breaking on. And also any other events will, I can just see a number tick up here for those. So here's why I leave this window open now. So as I'm debugging my application, and I was clicking this load by type button a lot, I can just see my memory graph just going crazy in the background here. It's just going up, up, up. And so this is cluing me in that I probably have a memory leak somewhere in my application. I would expect that not to grow so drastically every time I click that button. So let's use the diagnostic tools window to figure out what's going on. So I'm just gonna start by taking a baseline snapshot here. We'll just get the state of the world as is. And now pulling back up my application, let's click that button a couple more times. Right? So now I've clicked it several more times. You can see it's moving along. Let's take another snapshot. OK, so now I can see the diff in those two snapshots after clicking that button several times, and that's a huge number. I would not expect my heat size to be growing by that much. So when I click on it, it's going to open a view where I can compare these numbers, and then I clicked on the heap diff size, so it's bubbling that one to the top, and I can see that my app info container clearly has some issues going on here. It shouldn't be that big. I shouldn't have added 5 new ones. So what's happening is, there's a selection changed event handler. So I'm registering for this event, but I don't actually, I think one of my coworkers was helping trying to get that hooked up, but we don't actually need that right now. So let's see if removing that subscription helps improve my memory leak. So we'll exit out of here, go back to my application. We'll search for that. Oh, no, I want to do app info. That's what it was, right? App info container. So let's see. OK, so here's where that selection changed event is getting added. And now if I just comment this out, I'll have to break all. Don't be afraid of break all. You can go directly back to your to the line of code you're trying to edit. So let's go ahead and actually hit this breakpoint and not do a break all here. OK, so I've hit this breakpoint. Now I'm going to comment that out. Let's take another baseline snapshot. Let's delete this breakpoint, hit continue. Click that button several more times. And yeah, the memory increased a little bit, but not as much as before. And when I click on this diff, that app info container is nowhere to be seen. So I just use the diagnostics tool window to help me diagnose a memory leak in my application. OK, the last thing I mentioned over here was IntelliTrace events. So in the summary page, you can see that we have exception events and IntelliTrace events. Those events show up in this track on top here as little diamonds that are happening in your code. And so now that all my apps are loading, I mentioned I was going to do a multi-threaded kind of tips and tricks kind of at the end here. So let's move on into that section. And when I click on that, I get this error that says, "Oops, an error occurred. Whoopsie, my bad." So my app isn't crashing, so I'm throwing and handling some sort of exception somewhere properly. But when I have IntelliTrace open, in this summary page, I can see, hey, that was actually quite a few exceptions that were being thrown and caught. And when I go over to the Events tab, I can look at those exceptions. So I say, OK, this is a null reference exception being thrown and then subsequently caught. Let's activate historical debugging. So what this is going to do is this is going to take me to that exception line in my code where this exception was thrown. So I don't have to go comment out all my try catches. If I have IntelliTrace, I can just immediately step to that line and do an inspection and saying, hey, null reference exception occurred. One of these things must be the cause of my null exception. And I'll debug that in a minute. Great. So we'll just flip back over, just do a quick recap. I know we went through a lot in that one. So we talked about kind of breakpoints and diagnostics. Is anyone more inclined to keep the diagnostic tools window open? 5 people. Fantastic. My work is done. Just kidding. Just kidding. Seriously, try it. It's a challenge. OK, so let's go back to, I told you I was going to debug that null reference exception here in a minute. So, oopsie, an error occurred. If I don't have IntelliTrace, as many professional on VS Professional, VS Pro SKU don't have, how am I supposed to figure out that that exception was happening? Am I supposed to go through and comment out all of the try catches in my application? Heck no, right? So I can use the exception settings window. So this is under Debug Windows Exception Settings. And inside this window, it's basically you're able to say, hey, debugger, I want you to notify me when this exception is thrown. So it's kind of like an exception breakpoint to that degree. So I'm going to turn on my common language runtime exceptions here. CLR exceptions are .NET exceptions. And when I check that box, all of my common language runtime exceptions in this list, not in this list, they're going to be, the debugger's going to stop when those are thrown. Let's prove that. So now I'm going to click the parallel button, and I'm going to stop when those exceptions are thrown. This wasn't the exception I expected to stop on, right? Like with IntelliTrace, we saw that it was a null reference exception. That was really the problem, so I'm going to look at what's happening here. This exception helper is new in Visual Studio 2017. We got rid of both the modal dialog for C++ developers and the old dialog for .NET developers. And so we have condensed it to give you the information that you care about right in your face when you need it. So it's saying an system exception was here, something went wrong, and previously I would have had to drill into the inner exceptions over and over again to get to really what's happening. Oh, this registry key doesn't exist. Oh, now I'm remembering, I had a coworker that's working on this settings library, and they're trying to set registry keys. Well, they're doing some exception handling when this clearly doesn't exist, and I don't want to break on these things. I want to get to my code and get to the exceptions that I care about. So I'm really grateful that this inner exception was here, and I can navigate through these inner exceptions using these arrows. And so you can be confident that anytime you have an inner exception, we'll show that in your face. So also you might notice the exception settings down here got a little addition to them as well. Like I was mentioning, my coworker's working on settings library.dll. I don't care about that at all, so I don't want to break on it. I'm going to check this box that adds a condition to this exception that says, hey, break always except when this exception, so system.exception, is thrown from settings library.dll. And when I hit continue, I don't break on those exceptions anymore, and I actually stop on that null reference exception that I had cared about previously. So when I added that condition, you might be asking yourself, well, what if I did that on accident? How do I get it back? You can always use this reset feature down here in exception settings to reset your exception settings and remove the conditions. But you can also, just from this exception settings window, you can add a condition on all of the .NET exceptions. So we just did it for system.exception, but let's say I really don't care about this settings library. Let's add a wildcard and go settings. And so now everything that has settings in it, every exception that is thrown from a DLL or an XE with settings in it won't break. So I no longer stop on those exceptions that I really don't care about. Now, to this null reference exception that I heavily, heavily care about. The null reference exception was thrown, and remember how I said, oh, I'll have to go debug that later? I'm going to probably have to go break that apart and figure out which one of these things is returning null. When I'm broken in the debugger now, you can see right here, it's telling me, help simplify. That's the one that returned null. I don't have to break apart my code to figure that out. I've got it instantly, right there in my face. OK, so now I'm going to F12 to help simplify, and I just forgot it to do here, right? So I'm just going to add a new parallel simplifier and be on my way. Great, so now I'm not getting that error anymore. I'm able to get to this calculate screen. And for the sake of time, I was going to do a recap on some of our exception setting stuff. But let's just jump into our multi-threaded demo and show you a couple of those tips right now. Raise your hand if you do multi-threaded debugging. Great. Raise your hand if it's hard to debug multi-threaded applications. The same people, exactly. Debugging's never easy, but debugging threaded applications is extra hard. So I have a list here that's just calculating all of the primes from 0 to 50. It's calculating prime numbers. And when I read through this list, 2, 3, 5, 7, 9, 11, 19, 23, 20, 25. Wait. While I might think 25 is the prime of my life, I am pretty sure it is not a prime number. So let's go figure out why. So let's go control comma over to my number utilities class. And this is where I'm calculating these primes in parallel. So let's just set a breakpoint and start drilling into just what's going on. And I'll show you the tools as we go along. So, OK. This is one of those times where I'm going to get this out of the way so we have more space. And in my debug Windows section, we've got new windows that or not new, but little known about Windows that you can access for debugging multi-threaded applications. I'm going to start with the parallel stacks window. So when I open this window, let's hit this breakpoint. OK, when I open this window, you can see that it is a visualization of the call stack of my application for all of these threads. So right now, you can see that I have 6 threads here in external code and 1 thread in numberutilities.isPrime. Well, let's hit this breakpoint a couple more times. Now I can see that, oh, I have 1 thread here and 1 thread over here. This is the thread I'm currently stopped on because it has the yellow arrow. And I can visualize and trace down the execution of the different threads in my application through the parallel stacks window. If you're also working with tasks, you can use the tasks view in the same way. So that's parallel stacks. The next thing we're just going to look at is the parallel watch windows. So we've got a lot of parallel watch windows for you to use. And so let's just go ahead and add a watch on candidate here. And now I can see, OK, on each of these threads, this is what candidate is. Now you might ask yourself, well, where are these threads in my execution process? How can I see what those are? Well, you can use the parallel stacks to get an understanding. But what about visually? We have this button called Show Threads in Source. So when I turn this on, we will start to see these little thread icons show in my source code here. And let's hit another one. Oh, my breakpoint wasn't set, so it didn't get hit. OK. So as I hit here, shows threads in source should be showing on the edge here. But it's not, so I'm going to debug that issue later off screen. But the important part is that, hey, I can watch a variable over multiple calls to this one line. And so now I can honestly keep clicking this until I get to my issue, which was 25, right? And I can right-click over here. And one of the things I can do is I can freeze this thread. So did you know that you can freeze and thaw threads as they're running through your application? So when that guy's really happy about it. So I can freeze this thread. Thank you for being happy about it. I love this stuff. So I can freeze this thread. And now if I hit continue, I'll let all of the other threads run in my application. And another place that you can see all of those threads and what they're doing is through the threads window. And so I can see that giant list of all of those threads that are in my application. And I can see, OK, here is this worker thread, and that's the one I've frozen. And so when I push play, those will all run. This one will be frozen. And then I can thaw it and just step through that one. So then I could thaw it. Now, speaking of stepping through that one, raise your hand if you have this issue where you are hitting breakpoints on multiple threads. And you're like, I just want to step through this one thread execution. Yes, everyone, I have this problem too. Little known secret is that we actually will always complete a step on the thread we started from. It's the breakpoints that get in the way. So if you want to quickly and easily solve that issue, once I hit, we're going to start from scratch, because once you hit a thread at a breakpoint, we'll step between both of them. So starting from scratch, let's hit this first thread. And now I'm on that one thread. And when I remove this breakpoint and take a step, I'm going to logically step through this one thread in my application. And so if you have breakpoints that you can't remove, you can always use that filter breakpoint that I talked about earlier by adding a condition for filter on the thread ID that you care about. And I can see that this thread ID is 2312. So I could add that in here, and then I would only stop at that breakpoint on that thread. So hopefully those are some multi-threaded tips that will kind of get you through your day job. Let's go back and do a recap real quick here. Oh man, I rushed through that. Okay, so exception settings. We talked about break when thrown. We talked about the new exception helper. We've talked about inner exceptions in your face and also conditions on those exceptions. And then I want to point out that null reference analysis that I talked about earlier, it works for both .NET and C++. We'll show you that. And then the last thing I showed you was multi-threaded tips. So we talked about the parallel stacks window. We talked about the parallel watch window, show threads in source. And I have other resources online that I'll point out later that will kind of deep dive into some of these things to help you with those issues. So here are those resources. Don't leave yet. Remember, this is Marvel comic style. You can check out our blog at the diagnostics blog. The code from this demo itself is found at VSDiExamples, and you can pull it down, play with it, go step by step through the demos I just showed to get familiar with those tools that you have. And we also have the Visual Studio blog. Now, I think I'm the last of these sessions to go, but if you want to watch them online, here's a reference for those. Questions at the end, you can come up and say hi to me after this. You can follow me on Twitter, at Casey Sue. And I want you in the audience or watching online to take the survey to tell me more. How can we improve your debugging experience? What do you think of your debugging experience right now? I'd love to hear from you, and I will read all of those comments I'll read all of those comments and then try to connect with you if I can follow up. So that's the majority of my demo. Who's ready for a teaser? Woo! Yeah! Okay, so let's close these things out now and get that diagnostic tools window back here. Who has heard of the snapshot debugger that has been featured at this conference? Make some noise for that if you like that. Yeah. Well, I work on the same team as those guys, and we have taken that technology for collecting snapshots, and we've applied it to IntelliTrace. So like I said, this is a teaser that's coming in the future, but I'm going to step through my application here. F10, F10, step. Oh, thanks everybody. That'd be really a bummer if you didn't see that. So, stepping through my application, there was no trickery behind the mirror, I promise. So, I'm going to hit a couple of these breakpoints, come down here to this for each loop. Okay, I'm adding, a random index to my list. Hit that a couple more times. Okay, at this point, as I'm kind of stepping through here, what if I want to know what was the previous random index? That information's gone. I didn't hover over my data tip to see that, the first one I hit. But I want that information, and the random number is going to be different next time, so if I want to debug this time, that context is important to me. How many times do you wish you could step back? Guess what? We're making it so you can. So now I have this step back button. Yeah, woo! So now I have this step back button. So I can step back to the previous breakpoint that was hit. You can see I'm with IntelliTrace. I'm in historical mode. And now let's go look at that locals window, okay? How rich is this thing? I have all of my data that I've collected. Previously, if you've used IntelliTrace, we weren't that rich. And now, because of the snapshotting technology, you can get all of your locals when you're stepping through your application. And if I reset here, you can see this little snapshot icon means that we've captured a snapshot on that step. So if I go to this, I want to see what happened at this breakpoint in particular. I can activate historical debugging there, which takes me to that snapshot. And then it populates, not only am I on that line of code, I have that rich set of variables. So hopefully we'll be bringing that to you soon, enabling you to step back. And with that, I know it's a little early, but my demo portion's basically over, so I'll take questions from the audience, or we can not do questions here, and you can come up and talk to me afterward, or tweet at me. Cool, thanks for coming, everybody.